Okay, so today we're going to start talking about probability. So let's just go over some terminology that you're supposed to know. All right, so basic probability terminology. An experiment is the process that occurs when with well-defined outcomes. Outcome is a result from a single trial of the experiment. Event is a collection of one or more outcomes. Sample space is a collection of all possible outcomes. The probability of an event happening, which would be E, occurring is given by the ratio, P equals, that means the probability, the number of favorable outcomes, so that means how many times the event can actually happen, over the total number of possible outcomes. And you guys should know this, probability has to be between 0 and 1 inclusive, which means it can be 1 and it can be equal to 0. So you can't have anything that's greater than 1. So you can't have a probability of 1.5 or a probability of 3 over 2. And it can't be less than 0, which means it can't be negative. So it will be equal to 1. That's a certainty. So, for instance, a probability of a 1 would happen when I say, if you roll a fair die, and I said, what's the probability that when you roll the fair die, you get a 1, 2, 3, 4, 5, or 6? Well, that's going to happen no matter what, right? So that would be 6 out of 6, which is equal to 1. What if I said, what's the probability that when you roll a die, a fair die, you get a 7? Well, that can't happen, right? That's 0 times out of 6. That can't happen. That's equal to 0. That's an uncertainty. So we have a certainty that's going to happen no matter what, and an uncertainty will never happen. That's equal to 0. All right, so let's take a look at the different types of probability. We have empirical probability and theoretical probability. So this would be empirical probability. Karen flipped a coin 3 times, and below are her results. What is the probability that she got a tails? Well, how many tails do you see? There's 1 tail. Over how many outcomes were there total? 3. So it would be 1/3. That's the probability that you got a tails. All right, and then we have theoretical probability. A fair coin is flipped 3 times. The results is noted each time. Draw a tree diagram and list all the possible outcomes. All right, so hopefully you guys remember how to make a tree diagram. I'm just going to move this up. All right, so when you flip the coin the first time, you could get either a heads or a tails. That's the first flip. You get a heads or a tail. Then I flip the coin again. Let's say I got a heads the first time. Well, then the second time I flip the coin, I could get a heads or a tails. If I got a tails the first time, then I could get a heads or a tails the second time. So just because I got a heads or tails the first time doesn't change the outcome of the second flip. And then I'm going to flip again. So let's say I got a heads first, a heads second, and then I flip again. I could get either a heads or a tails. If I got a heads first, tails second, then the third time I flip, I could get a heads or a tails. If I got a tails first, a heads second, then I flip again, I could get a heads or a tails. The third time, if I get a tails first, a tails second, I flip again, I could get a heads or a tails the third time. So notice that if I said to you guys now, what's the probability that when I flip a coin 3 times, I get a tails? Well, actually, theoretically, I could get a tails. There would be 1 here. There's a tails here in this path. There's a tails here in this path. So there'd be 1, 2, 3, because there's 2 tails here. 4, 5, 6, 7 out of 8 times I could get a tails. Now, it does say to list, so this would be my tree diagram, and to list all the possible outcomes. So this would be my list. So I could get a heads, 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 tails. Heads, tails, heads, heads, tails, heads. Heads, tails, tails. Tails, head, head. Tails, head, tails, 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 head, and tails, tails, tails. So you can see there's different ways that you can get. So if we look at the first one, which when I flipped the coin, I got the tails only once. Okay, but there's other ways that you can flip the tails. It might not come the first time. Maybe it comes the second or the third time, or maybe it comes multiple times. So to get a tails, it would actually be 7 out of 8. That's theoretical that you'll get it 7 out of 8 times. Okay, so now let's just talk about the counting principle. So I'm just going to move that up. And this should be familiar because you should have done this probably maybe 7th or 8th, probably 7th grade. Okay, so let's say you're going out to eat pizza for your birthday. You have 3 choices to make. Your crust can either be regular or thin crust. Your cheese can be regular, low-fat, or extra cheese. Your toppings could be vegetarian, barbecue chicken, or pepperoni. How many different ways can you choose your pizza? So that's saying I could have a regular crust with low-fat cheese with barbecue chicken. I could have a thin crust with low-fat cheese and pepperoni. How many different combinations can we make for a pizza? So you take how many crusts you can have. You have 2 crusts. You have 3 different types of cheeses, and you have 3 different types of topping. So if you look down here, it says, if one event can occur M ways and the other event can occur N ways, then both events can occur M times N ways. So I take all these different ways and I multiply them together. So I have 2 times 3 is 6 times 3 is 18 different ways to make a pizza. This is called the counting principle. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.